From the materials section of the course, we're going to be looking at something called the Young's Modulus. The apparatus I've got in front of me is some blocks which I'm going to use to anchor the wire using the clamp to the bench. It's going to be stretched across onto a bench pulley, which will be mounted on the edge of the bench, and the wire will be stretched by adding these different slotted masses. At the same time, I'll be protecting the floor using these bits of cut up yoga mat, and of course protecting my eyes using some safety glasses, even though I'm wearing spectacles. Another thing is I will be putting some bridges across the wire, which will reduce the potential of any injuries if the wire snaps, by just providing some resistance to the wire as it comes up. The first thing we need to do is to secure the wire as close as, to the bench. To do this, I'm taking the wire, I'm using constantan, and this is approximately 30 SWG, which is standard wire gauge, not to be confused with the American system AWG. I'm just wrapping that a few times around the block here before I clamp it at the edge. The reason I'm doing this is it's going to provide a bit of friction, but the main point of the clamping force will be at on the wire right at the edge of the blocks here. So the only ability for the wires to stretch will be from where it's released from this clamp. So I'm clamping directly above where the wire joins the blocks. So that needs to be done fairly tight. You notice I'm not that the wire is not being unrolled from here. That is to prevent any kinks, etc., being developed as it gets rolled out. The wire is now unravelled across the whole length of the bench. Now ideally we would need a longer bench, and then we need to put the bench clamp on, make sure it's securely fastened, and measure off a little bit across here before making a loop. Now I should use a pair of wire cutters to cut this. I now make a very simple loop in the end. In order for the masses to be suspended from that. I am putting a mass on here just to provide some tension, and placing the protection onto the floor. Although there's only 100 grams here, I'm going to put my glasses on, safety spectacles, and place these protective bridges across there. I now need to measure the zero length, the original length of the wire. So I'm going to have a data of my baseline, which I'm going to use this tape measure to provide there before creating a mark using some of this tape here, and I'm going to go for 180 centimeters. The changes we're going to be looking for in this are very small. So what we want is some method of determining the small changes in length as the extra masses get added. And one of the other factors we've got to consider is what else could cause an extension. And one of those is temperature. So during this process, I'll be using this thermometer to measure any changes in the temperature, and I'll have it on max and min so I can see what temperature changes has occurred. The changes are going to be small, so what I'm going to suggest as a means of measuring very small changes is this, which is a travelling microscope. How it works is you have a scale which can move and can be locked in position here, and a screw which gives very precise adjustment of the vertical position. So this telescope's looking down at our marker, and you can get very precise control on where it is in relation to the ground, to the original position. It has a Vernier scale on the bottom, so you'll need to know how to read a Vernier scale, and this needs to be mounted vertical. There is a stop at the top, a marking to indicate when it's vertical. So this is actually used to measure distances either vertically or horizontally, because you can mount it like that for doing vertical, or what we're intending to use it for, horizontal. So this is effectively how I'm going to have it. So that's going to be the scale is now readable to me. I'll lock that in the vertical position, and the slide I'll need to set up over there, and I'll do that in a second. I have secured the end of the tape, the far end of the tape, to the desk using a piece of masking tape, which is butting up against the blocks holding the wire. So we can now get a more precise determination of the length we are looking for as our original length. So we have that there. As you can see, it is slightly over 180 centimetres, but I'll leave you to decide what you think that is. I now need to take some measurements of the thickness of the wire, and to do that I'm using this screw gauge micrometer, which I'm going to put every foot, that well-known metric unit, every 30 centimetres or so, and take a reading from the micrometer. I'll be doing this, repeating this as I go down, but I'm going to be giving you some still images so you can look at those values yourself. I'm now going to place the travelling microscope so we can measure how far our datum travels, how far our marker travels. But you'll notice there's one thing. If I bang this table, there's a possibility of the travelling microscope sliding. prevent that, I'm going to place under each of the corners of the travelling microscope a blob of blue tack. Now this should provide enough adhesion to the level so that it doesn't move. But what I will do is move this so it's in a better position. Now what I'm going to do, all the direction of travel is going to be that way, so I want to make sure that I'm going to have enough play on this. So I'm going to move that first. Okay, now release, zero that again, release the block here, make sure that I'm reasonably tight against that edge, and move the scope so that it's over the flag that I have on the wire. Once in position, I will lock it and adjust again to get our zero. So we now need to focus and adjust the zero. So the first thing to do is focus and then adjust. Right, that's the end there. Because I'm slightly off centre, I'm going to turn the cross on the microscope eyepiece. Take out any error and make it an awful lot easier to follow. So that's going to be our zero, and we now need to go down to look at the Vernier scale. In the normal case of using this, we'd be using the microscope, the magnifying glass here, to determine the position of the zero of the vernier to make sure it lines up. But this is not going to be necessary in this situation because we'll be able to take the values directly from the photograph and inspect it that way. You can see in the image that the zero of the vernier is just beyond 6.7. I'm going to include an enhanced image which is both sharpened and slightly enlarged, and you can see that it is definitely beyond 6.7. We now need to try to get a better precision from this vernier. If you have a look at the lines and how they line up with the vernier scale top and bottom, you can see that, as a suggestion, 6.710 gives you a very good line-up. You will be required to take the next series of images of the extensions from the scales as various loads are added. The loads will be displayed on the screen written in pen. Having taken our zero, I'm going to put the glasses on because I'm going to be adding masses here, and there is a severe possibility of injury from this. So I'm putting 100 grams in on the hanger, letting it stabilise, and then we'll take a reading and see where the marker has moved to. It may be that this is insufficient and I might need to go up in 200 grams increments, but we will see. So with 1.7 kilograms at the side, mass on the end, I'm going to call it a day here.